Let's talk about functional dependencies. So as we've seen, it's important to be able to select the keys or the combination of fields that make that identify a particular record as being unique, and the combination that you choose can enforce certain rules, right? Whether to enforce the fact that that a particular combination needs to happen only once, and this in turn can enforce certain constraints, right, that are implied in the class diagram. Now, functional dependencies is yet another technique that can be used to identify certain dependencies, some constraints that are specified in the requirements. Okay, and sometimes you can enforce them, sometimes you can't. In particular, we would like to identify what dependencies might exist between fields that are not primary keys and fields and other fields, right? That between fields that are not primary keys or foreign keys, right? We certainly want dependencies or constraints between foreign keys and primary keys, right? Because they establish some relationship between one record and another record, right? And that is a good thing. We want to be able to say, well, this record is associated to the other record over there, right? And maybe establish some rules between them. But what about, instead of relationships between one record and another record, how about relationships between a field and another field in the same record? Okay, we would like to explore those as well, right? For instance, right, if there is a relationship between one field and another field, right, it might be a clue that there is some redundancy there that we might not want, right? If you know one field and it implies a particular value on another field, right, that might cause some redundancy, some inconsistency, right? Because if you know, for instance, that that a car model is a Toyota, right, and I'm sorry, that a car model is a Corolla, and the manufacturer has to be Toyota, right? That means that there's an implication between the two, meaning that if you know the model, you definitely know what the car maker is, right? If you know it's a Corolla, well, it can only be a Toyota, yes, right? If it's a Camry, it can only be a Toyota, right? And so these might be two fields of the same record, and there is a dependency between one and the other. Make sense? Right? So if we notice that there might be no way for us to enforce the constraint between one field and another field in the same record, correct? For instance, there's nothing that would stop us from saying a Corolla is made up by Ford, for instance, right? So that if we cannot enforce the fact that we cannot insert those kind of bad data, then we are introducing inconsistency. So we want to be cognizant, right, of identifying any dependencies that might occur between one field and another field, because it might cause inconsistency. Make sense? All right. So let's take a look at these relationships between one field and another field, and when we find them, we want to remove them. We want to say, well, no, this should not be a dependency between one field and another field. It should be split into a separate table. Right? That's a clue that instead of having Corolla, Toyota in the same record, that's a clue of telling you that perhaps these should be separate tables. That there should be a car model in one of the tables and a car maker in a separate table, right? And there should be a one-to-many relationship between Toyota making a whole bunch of models, right? Corolla and Camry and 4Runner and whatnot. Make sense? Right? So certainly we would like to identify dependencies between fields that are not keys, they're not primary keys, they're not foreign keys. We want to eliminate them, right? But then also consider relationships between fields that are primary keys, right, and fields that are not primary keys, right? In that case, we do want dependencies, meaning if you know my phone number, hopefully I'm the only person associated to that phone number, right? It would make no sense that that phone number be associated to more than one person. Right? So that's a clue of telling you that perhaps the phone number would be a really good primary key, right? Because it would force the fact that there's only one identity associated to that one primary key. Okay, so identifying a functional dependencies between non-key fields gives you a clue that perhaps one of them should be a separate table, right? And we want to eliminate those dependencies between non-keys. But in the same token, dependencies between primary keys and other non-primary keys, right? Those are actually desirable. It might actually gives us a clue that perhaps one of them should be a primary key, right? That if I have a function, if I have a field that is a phone number and another field that it identifies me as a person, perhaps the phone number might be a good choice for a primary key, right? If it makes sense, right? In the logic as you are trying to consider which should be primary keys, which should not be primary keys. Make sense? So functional dependencies are very good strategy to explore what could be a good choice for a primary key or not, right? Or whether we would want to normalize and split tables into separate tables. So let's look at functional dependencies as a concept. For instance, here's an example of a table where we have some data that represents students, represents the semester that particular student is in, and some lectures that student is attending to, right? And some of the TAs that are associated to those particular lectures. Now, notice that we have here the ID of the student 1201. We're also capturing the fact that particular student is in semester 4. Okay. Well, in a separate record, we might well, in this particular record, it shows that particular student is taking a look at a particular lecture called numerical methods. Yes. In a separate record, we're saying that the same exact student is also looking at another particular lecture called Physics 2. Make sense? Now notice that the two records, it would be improper for the data here to show that student 1201 here is in semester 4, but in another record showing that the same exact student is in semester 5. That would be would make no sense, right? The same student cannot be in two different semesters, right? So this would give us a clue that perhaps there's a relationship between these two fields, right? That if you know who the student is, well, that student can only be associated to that one particular semester, right? And it cannot be that it's in some other semester. So there is a relationship between the two. If you know the student, you know the semester. That person can only be in semester number 4. Notice that this dependency doesn't go the other way around, right? That if you know the semester, it doesn't necessarily imply the same student. There might be thousands of students in that same semester, okay? So typically these relationships flow in one particular direction, right? It flows that if you know one, perhaps you know the other one, but not the other way around. If you know the other, it doesn't know that you know the one. Make sense? So the relationship flows one way. So typically we say that we document it as follows. We say that if you know the student ID, it implies a particular semester. Yes? Right, with the arrow pointing in the direction of the dependency. Make sense? Right? Another way that we can say is that the semester is a function of the student ID. Meaning, if I know the student ID, it uniquely identifies what's the semester of that particular student, right? And it's a function, meaning that for the same value that I give it, right, I'm always going to get the same result. It's a function, meaning there's no state, right? It doesn't remember anything from the past, right? For the same value, we'll always get the same output. It's a function. Make sense? And just like a generic function, y is equal f of x. Okay? Now these, yes.
Can a course number and the course name would be a one-way relationship? Because it can't be another way. Like if machine learning is offered in two different departments,
Right, exactly, right. So if you know a particular course number, then you know exactly which department might be offering that, right? So there's a dependency between the two, right? So that's exactly what we're trying to point out here, right? That if there might be a relationship between two fields, and that's going to help us identify to choose either one of them of how is it that we would enforce to avoid any inconsistency. Right. That. Yep.
To follow up with that, if you want to also include the information about which department is it offered, so will it be a good practice to include the department in the same table, or to create a new table for different departments where the course and
Exactly, and this is the topic. The topic is that this will give us a clues on whether it should stay in the same table, or it might be better to split it up into two different tables, right? So there's two things there. One of them is between dependencies of fields that are non-keys, right? Or fields that are non-keys that depend on a key, right? Those are okay. We want to keep those, but we want to eliminate the ones that are non-key relationships. So it gives us a clue on choosing these keys, right? Either one of the ones that are non-keys, perhaps it's telling you that perhaps one of them should be a key, right? Or instead that it should be a completely different table, and we should split it up into a different table. So those are decisions that are driven by identifying the functional dependencies, right? So we'll look at a normalization in the next presentation, but this is a segue into that discussion, right? On when to split it when you break certain constraints. Okay. So notice that here we're not yet talking on whether the student ID should be a primary key. It looks like it's not, right? Because notice that it's repeated twice here. So probably this was not the intent of this field to be a primary key, right? So, and same thing here for the semester. It looks like it's not a primary key either, and the combination looks like it's not a primary key either. Right, so it looks like these are non-key fields that depend on one another, right? And we see what problems we could have here, that there's no way for us to enforce or to identify or to stop someone from entering bad data here, right? That they could they could update the student ID and update this to be something else other than 4. Yes? Right, so we would want to identify either some way of stopping this, of restructuring the data, right, in some way that it would not allow entering that bad data. Okay. Okay. So this one is pretty straightforward, right? That these depend on one another, and so it's somewhat trivial, identifying these problems. But not necessarily. Sometimes the dependencies might be a little bit more subtle. Okay, and also depending on a particular phrase or a particular requirement that is specified in the specification. Okay, so some of them might be that that a particular TA might be TAing for a particular lecture, right? That if for instance if you know the particular student that is in a particular lecture, then that might imply that there can only be one that a particular TA because you know the particular lecture, right? Given a lecture, there can only be one TA that is associated to that particular lecture, right? Again, this might be a little subtle, perhaps a little more obscure to identify these relationships between lecture and TA. Also, it might be that the semester would be for the TA, but not for the student. That if you know the lecture, you know the TA. If you know the TA, you also know the semester. Again, it might be depending on how you interpret or you read the specification. You identify these logical dependencies between the fields. So some of them might be explicit. Some of them might be a little more obscure. So formally, the way we specify these dependencies is using the following syntax. We say that a set of fields, if you know some set of fields, if you know the values of those fields, it might imply that you know also the values of some other set of fields. Okay? It might be just one field implies a value from some other field, or maybe a combination of fields implies a combination of other fields, right? Now, the nomenclature here is that we read it as X functionally determines Y, right? If I know X, I definitely know Y, right? One implies the other, or that F is a function of X, or we say that there's a relationship between R between Y and X. Okay, so those are just formalities on how we describe this. All right, so let's take a look at some examples from our university database that it's a theme throughout the semester, where you might have a one-to-many relationship between a course and a section. Okay, and so let's explore some requirements that we might have read as verb phrases in our specification. So, for instance, we might have read in our specification that a professor can only teach one course. So the professor can only teach one course. So that immediately, just by reading the phrase, immediately you see a dependency. Meaning if you know the professor, well, you know exactly what they're teaching. They can't be teaching anything else, right? So there's a one-to-one relationship between the two, right? Nevertheless, we had this original data model where you had a section, had the professor who's teaching that particular section, and the year offered when that section was offered, and there's a one-to-many. You have one course being taught. One course having many sections teaching for that one course, right? So the relational schema for this might be that you have sections that has a unique identifier, a foreign key to the course that is associated, the professor who's teaching it, and the year offered. Notice that because of this relationship, the professor, right, and the course ID, there's a relationship between the two. If you know the professor, you definitely know the course ID. Yes? So notice that the course ID is a foreign key. It's not a primary key, right? So we can't enforce any uniqueness or any relationship between any other field. That means that in your database, you could inadvertently, enter bad data here, right? A professor with one course, but the same professor in a different section teaching some other course. That would be a bad data, and there's no way for us to enforce or stop somebody from entering that bad data. For instance, there's nothing in this relational model that would stop us from entering the fact that Einstein can only possibly be teaching physics. There's no way that Einstein would also be teaching dance. All right? This would violate that rule, but there's no way for us to stop somebody from entering that bad data. Yes? Right? And that's exactly what the point of functional dependencies between non-key fields. These fields are non-key, right? They're not primary keys. They're not uniquely identifying the record. The only primary key here is the section ID, right? The course ID is just the course ID here is just a foreign key to some course. Make sense? All right. So this record violates our rule, but as far as the database is concerned, there's nothing wrong with Einstein teaching dance. Okay, there's nothing wrong with that. And so functional dependencies immediately is a red flag telling us that there's a risk of inconsistency. All right, so it's important for us to identify them and to eliminate them somehow. All right, so first we have to try to identify them. Okay, so redundancy, you could have inconsistency. And the way you would fix it is perhaps you would split this, right? You would split this into two tables of courses and professors, and we'll take a look at that when we look at normalization in the next set of slides. So functional dependencies. Again, some jargon here. You have the left-hand side implying the right-hand side, or X implies Y and whatnot. Just more. All right. So let's take a look at this. So this rule. Here's another rule. We first looked at the professor can teach only one course, and we already immediately identified the functional dependence. Here's another one. It says all sections in a year must be taught by the same professor. Right? Again, this one's a little more subtle. Right? This says that the combination of section and year immediately implies who's teaching it. Right? So if you know the where is it? Right, it introduces a constraint, right? By knowing the section and knowing the year, the combination of those two implies the professor, right? So the combination is that the set of fields of course ID and year offered immediately identifies me who the professor is. Yes? So sometimes it's between just one field and another field, and sometimes it's between a combination of fields and another combination of fields. Right, that they uniquely identify them. Right? It's a functional dependency. So yeah, so in general we say that we might have x1, x2, x3, so any combination of fields implying some other combination of fields. So here's a couple more, just examples of them. Right, so all sections that professor teaches are from the same course. Right? So that means that all sections professor teachers are from the same course. Courses taught at most once a year. Right, so these are combinations of courses and the year that they were offered and the section that they're teaching. Right, so these are just other examples of various functional dependencies. So here's a couple of here's a sample data set, right, of Einstein and Bohr, both teaching physics at different times at 1950 and 1951. And as far as the database is concerned, there's nothing wrong with this data set, right? But if you look at the different functional dependencies that we find, we'll see that this data set violates some of the dependencies that we might introduce. But there's no way for us to enforce any of this, right? So if you have here professor, if you know the professor and you know the year offered, you know exactly the course that is being taught. So for instance, we notice here that Einstein in physics, that Einstein in 1950 is teaching physics, right? And Bohr in 1951 is teaching physics, right? So those four records match the functional dependency, right? That they don't violate the functional dependency. Instead, we see that Einstein in 1951, right, is teaching physics, and that violates the functional dependency. See that? But there's no way for us to enforce it. Okay. So here's another one where you might have course ID and the year offered knows the section. Again, some of the records don't violate this rule, but certainly there are quite a few records that violate this rule. Yes. Again, there's no way for us to enforce any of this, right? Other than perhaps breaking it up into separate tables or identifying primary key combinations. All right, so that's the idea of how dependencies between non-keys, right, can cause us to have ambiguity or have inconsistency. So perhaps they are a clue that one of the fields perhaps should be a primary key, right? That it gives us a clue on what fields that should be a part of the key. So what we'd like to be able to identify is that what we'd like to end up with is that a key, right, uniquely identifies the rest of the fields, right? That's actually a functional dependency that we do want, right? Like if I have my phone number, it uniquely identifies me, right? So ideally, that phone number might be a primary key. It cannot repeat, and it can only be associated to my person. Yes? So dependencies between primary keys and non-primary keys, those are desirable, as opposed to dependencies between non-keys are not desirable. All right? So in that sense, dependencies can help us identify the keys. Yeah, so functional dependencies can help us determine what the keys are. Here we are using the more generic term superkeys. If you remember, superkeys is a set of fields that uniquely identify me, but it might include some superfluous fields, yes? Some fields that don't necessarily make me any more unique, right? For instance, if I already have my phone number, my last name would not make me any more unique, right? My phone number would be plenty to make me unique, at least in this planet, right? When we settle Mars, then we'll need additional keys, right, to make us unique in the solar system. But for now, the phone number is enough to identify us uniquely in this planet. So the minimum set of fields that make us unique is called just plain old key, right? The key. We say that a super key that has superfluous a super key that has might have fields that are superfluous, that don't make us any more unique. So here's establishment that some of the fields that you have a dependency might actually imply that some of these fields might be a good candidate for using them as keys, right? When you identify these functional dependencies, that the ones that are on the left-hand side would be perhaps a good candidate to be keys. Now, if there's a dependency between keys and non-keys, we say that it's a full functional dependency, right? Where we have some of the fields on the left-hand side being identified as keys, and then having those non-key fields, we say that there's a full functional dependency. That's a good thing. We want those dependencies, right? Dependencies between keys and non-keys. We want to keep those. So we're looking for full functional dependencies. Those are the ones we do keep, and we don't want to keep the dependencies between the non-keys. So non-key based functional dependencies are immediate giveaway that might have a risk of inconsistency, and we should avoid them at all costs. So immediately a non-key based functional dependencies is an immediate red flag, right? That you're going to have a risk of inconsistency. Instead, we want to find the full functional dependencies where you have the dependencies go from keys to non-keys. So the question might be, well, why do these even happen, right? Why do we have even these dependencies between fields? Where do they appear, right? Did we not choose the data model correctly? Where did they come from? So let's look at some examples of where these functional dependencies might appear, right? Between the non-keys, where might they appear? So let's go back to the example of the university, and let's deliberately introduce a functional dependency. Okay, right? So for instance, if you remember, we had the data model where you had a student associated with an optional permit. Yes? And that permit might catch information such as the license plate of the vehicle, and in that case, I think we were only capturing the car model, right? Whether it was a Corolla, a Camry, a Wrangler, or whatnot. But now let's add deliberately, right, an additional field that we want to capture. Okay, for instance, and not only do we want to capture the license plate, the car model, here we're going to add, I want to capture also the car manufacturer, right? Who made the car? All right, this is going to cause a functional dependency immediately. See that? Right? If I know the car model, I obviously know the car manufacturer, right? Not the other way around though, right? If I know the car manufacturer, I don't necessarily know what the car model is. Okay, so the functional dependency goes from car model to manufacturer. Okay, all right. So a sensible way of modeling this would be that there would be a one-to-many relationship between the car maker and makes many models. Toyota makes lots of different models, right? Jeep makes lots of different models, and so on and so forth. So this would be a sensible way of capturing this. But let's say we deliberately choose not to capture it this way, right? Somebody would have, as might have made the following sensible. I'm sorry. Here's an example, right, where we have, lots of different permits that were all given to lots of different Corollas. Here's a whole bunch of them that were given to lots of different Cherokees. All of these car models might be all made, manufactured by Toyota, and all of these made by Jeep. Yes. So this would have been a perfect way to model this. Yes. But let's look at a completely different, sensible way that we would have captured this. For instance, we might have decided that this was way too much work, right? Of splitting it up into 3 different tables, right? I mean, we're not a car manufacturer. We're not the Registry of Motor Vehicle. We don't need to capture, such a detailed model of this, right? We might have instead taken the following shortcut, which might have been a sensible choice, right? Instead, we would have decided to, instead of having all these 3 different tables, we would have captured maybe everything in a single table, the permit table. Yes? We would have captured the car model, the car maker, the student ID, the license plate, everything in a single table. This might have been a sensible choice, right? It would have been a naive choice, right? But it would have been maybe an okay choice. Notice that we have a car model and the car maker in the same table, right? Now, our knowledge of the way cars work, we immediately identify this being as a functional dependency. We might not be very knowledgeable of cars, right? And we might have not known that there's a dependence between these two, right? It would have been sensible, especially if you don't know about the domain, right? If you don't know about the domain, this would have been maybe a sensible choice. But after reading up on car makers and car models, we identified that this was a bad choice, right? If you know the car model, that immediately implies who the car maker is, right? If I know it's a Corolla, it has to be a Toyota. And now that we know that we have this functional dependency, we need to weigh our options. It says, oh, maybe this was a bad choice. We might decide that the bad choice is a low risk, right? That maybe we can deal with this at the application level, and we have drop downs, and the user interface can deal with this. That if we choose the car model, it immediately populates the car maker, right? So it would be very, very unlikely that this would be inserted into a database with the bad data, right? Because we're validating all this at very, very early on in the user interface, and the user interface would never allow us to introduce the wrong car maker for the right car model. And maybe that we would be okay with living with the occasional inconsistency, right? Again, that would be a business decision, whether we are okay with this not being a very life-threatening inconsistency. We'd be okay with living with this inconsistency, or not, right? That's a choice that we would make at the business level, because we would point out to our system experts, our users who are going to be using this, of the potential risks, right? That we can introduce some redundancy here, right? That Corolla and Toyota, we could inadvertently, for instance, introduce the fact that Corolla was made by GM, or that the Corolla was made by Ford, right? And that our choice of modeling, leaves us no way to enforce or to identify these errors. And again, it could be that the university says, you know what, that's very unlikely that's going to happen. We can deal with that at the user interface, and that would never happen, right? So I'm okay with that, right? Instead of burdening the system administrator with dealing with 3 tables, having to maintain those 3 tables, and it's okay that they choose to be one table. Anyway, or we might decide to do the right thing and break up the table into 2 tables, and says, you know what, I don't want to have this inconsistency, and instead of these being these 2 fields in the same table, we're going to split it up and have car maker be in a separate table, right? And we're going to enforce a relationship using referential integrity, one having a foreign key to the other, right? And now we can enforce the fact that Corollas are only made by Toyota. Here's another example where we might have captured relationships between professors and sections and courses, and we would have sensibly captured the fact that you would have a professor associated with many sections, and also one course associated with many sections over here. Okay, but say here we had another relationship, another description in our specification that might have explained that a professor teaches exactly one course. Yes? Right. How would we capture that? Notice that this relationship of going from professor to section to course does not capture that. Right? It doesn't capture the enforcement that a professor teaches a particular course. Instead, we would have to explicitly go from professor to course, right? To capture the relationship between a particular professor and a particular course. But somebody might have decided that there's no real need to capture that because I might have already captured it here in this relationship. Right? That could have been a sensible bad choice, right? And we would have just captured here the relationship between the section going to the professor and going from the section also going to the course. Right? You have these 2 foreign keys going from the section to the professor and from the section to the course. Right? So having had that choice, notice that just by introducing that rule, we now see that we have a relationship, we have a functional dependency between a professor and the course, right? Because it says the professor teaches exactly one course, meaning if I know the professor, I also know the course ID, right? And notice that they're both non-keys. See that? Since they're non-keys, there's no way for us to enforce this relationship, right? We could inadvertently, for instance, in one record say that Einstein teaches dance and Einstein teaches English, and there's no way for us to enforce it. So to fix this, right? We'll see a little later. Is that we would normalize the relationship, right? By splitting it into a separate table, right? Instead of having both the professor and the course in the same record, we would split it off into its own table, right? And create a reference between the sections saying what professor is being taught, and now we have an explicit relationship between the professor and the course that they're teaching, right? So now we have that professor can only be teaching the course ID. Now the dependency is from where? The dependency is this course depends on the professor ID. See that? Right? And it's depending on what? It's depending on the primary key, which is exactly what we want. Right? All the fields, ideally, would only ever depend on the primary key and not amongst each other. Just like the fact that I'm Jose Annunziato, blah, 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 and I am associated to a particular social security number, that's good, right? It makes sense that only I have that social security number and no one else, right? That if you know the social security number, it's me. Or that if it's me, I only have that one social security number. Same thing here, that if I know the professor, I definitely know what you're teaching. Okay? All the dependencies are on the primary key. So those dependencies we do want to keep.